Okay, guys. So we're talking about glycolysis. And the very first thing I'm going to do in relation to glycolysis is I'm going to color my carbon atoms. So we have all of our purple carbon atoms. And there's a lot of atoms to track. So, okay, color. I'll go back and color them fully. But I just want to make sure we're seeing all of our carbon atoms clearly. And I made all the carbon atoms purple. Okay, almost there. Keep going. Purple carbons, purple carbons, purple carbons, purple carbons, and even more purple carbons. Okie dokie. So with our purple carbon atoms, and notice that one specifically is part of CO2. Okay, so we've got all our purple carbon atoms. And we have to invest. So we're going to have an energy investment. Investment. Meaning we're going to put in some energy. Specifically, we're going to have 2 ATPs. They're going to be used to phosphorylate. And break glucose into 2 molecules of G3P, which may or may not sound familiar to you. So I am going to take my ATP color and I'm going to color in my ATPs. And remember, when we remove the energy and take off that third phosphate group, it becomes ADP. And this time, notice where the phosphate group went. And so I just want you to notice that we have phosphorylated or added the phosphate group onto each of these. And we can track that phosphate group for a little while. Okay. And so I keep seeing my phosphate groups that we added on from the ATP. Okay. And then once we have gotten that glucose broken, think of it this way. When you have a bowl of sugar sitting on the table, it just sits there and sits there and sits there. But if you put a little effort in, you can dissolve it in water, you can do all sorts of things. And so the idea here is we've got this glucose that's just sitting there. But by adding the energy and therefore the phosphate groups, phosphorylating it, it allows it to break into our 2 G3Ps. And so once we have put the energy in to start the process of breaking it, we're going to have our energy harvesting. Okay. And so we're going to see how much energy can we actually get out of this. Because ultimately, the whole purpose of cellular respiration is to get usable energy for the cell, organism, whatever it is, so that it can do its job. So our G3Ps, making sure you can still see it on my camera here. Okay, G3P is converted to a substance called pyruvate. You'll often also hear it called pyruvic acid. And in that process, we get two ATP and we get one NADH. Now make sure you're paying attention. It's NADH, not NADPH. So I took my G3P and I went from NAD to NADH, which it's another one of those energy molecules. Now, it's not ATP, so obviously it's not usable by the cell. But nonetheless, and just like we did and every other time we got our electrons accounted for. Okay. And then I have my two ATPs. So at this point, technically, if you think about it, we have now replaced the original ATP that we used. So there's no energy loss at this point. And we know that we're going to get some sort of energy from our NADH. So that means we're for sure going to gain some energy. But notice that we've only done one of the G3Ps, and we have two of these, right? So we want to make sure we remember this is times 2, because it's for both of the G3Ps, we have to do the same thing. So for the other G3P, we got our NADH. And you know, that's actually one of those big things that's going on in a lot of the trends. They're really pushing, and you're seeing a lot more stuff talking about people taking or supplementing NAD+. I know when you see it on TikTok, you get to see all those wonderful ads where they're talking about those like stickers. I mean, there's all sorts of crazy stuff on there. But the idea is that there are people who are supplementing the NADP plus in hopes of speeding up their energy and metabolism process. Which, if you think about it, makes sense, because if you've got more NAD plus, then you can make more NADH, right? But that's also working on the assumption that we are in the process of extracting energy. And so they use it, a lot of times people are trying to use it for a weight loss issue, because if you start breaking down like the stored fats and things like that, it would come in handy to turn it into usable energy. So we end up with a total of, let's see, so what did we put in? We put in glucose and 2 ATP, and we get out pyruvate, and remember, we're going to get times 2 for 1 glucose. We get a total of 2 NADH, and we get a total of 4 ATP. So net, if you think about it, our net outcome, we get 2 ATP, 2 NADH, and 2 pyruvate. And we say that we get the net because we used 2 of them to start with, and so it's nice to know that we at least replaced it. Every single living organism will do glycolysis. Every single living organism. So even bacteria do glycolysis. The question then arises, do we have oxygen present or do we not? When we move into some of our eukaryotic cells, we have the further processes that we can do. And that's where the mitochondria will come into play, because we all know from 7th grade, they keep telling you that mitochondria is the powerhouse of the cell. What they're really saying is mitochondria makes it possible for us to extract more energy from the food source. So the initial, without the mitochondria, you can see that we don't make a lot of energy. And in reality, we haven't figured out a way to exchange our NADH. So if no oxygen is present, we need to have a way to kind of carry it a little bit further. And so that's where this fermentation concept comes into play. Let me just shift that a little bit to make sure that you can see the bottom. So this is in the absence of oxygen. We do what we call anaerobic respiration. And so the idea, anaerobic respiration, whenever you put that "an" in front of it, it basically says it's the opposite. So aerobic respiration, I always think aerobic, air, so it's got oxygen in it. So anaerobic is, the idea is that we really don't have that usable oxygen. And so we will go through this idea with fermentation. Because it will regenerate the NAD plus, so it's available for glycolysis to use again. Because once we run out of the raw materials, unless we can recycle it, we can't use it again. I forgot the U. U-E. Okay. So within this idea, we can take the pyruvate and we can break it down. And so we take that NADH that we created, which we haven't been able to exchange because so far we haven't come across anything that allows for it to exchange the process. And depending on the organism and the materials and systems that are built into that organism, they will either go through lactic acid fermentation or they will go through alcoholic fermentation. So how do we know in general, as a rule, what goes where? Lactic acid fermentation occurs in animal cells. Okay. And alcoholic fermentation occurs in yeast and plant cells. Okay. So you'll notice with lactic acid fermentation, during this process of breaking down the pyruvate, obviously we're releasing the energy out of the NADH and providing with NAD again, so we're recycling that. But notice in this process we have lost our little phosphate group that we had added on originally. So we have that, and we have removed that in the lactic acid fermentation. But the substance, the lactic acid, still has 1, 2, 3 carbons on it. And this is why your muscles actually hurt when you exercise a lot, because you exercise faster than your muscle tissue can get the oxygen present. So ultimately it's going to go through lactic acid fermentation. And so you're adding this extra substance into those spaces in the muscle. And the more stuff you try to put in a same space, the more pressure it has, which is what causes the pain. Eventually, your body will gradually break it down, remove it from the muscle, dispose of the materials that it cannot recycle, and recycle what it can. Now, if we look at the other pathway with the ethanol is what is created, and notice that is a 2-carbon substance. Our 3rd carbon goes off and becomes part of a CO2 molecule. So alcoholic fermentation makes ethanol, which is a type of alcohol. I know that because of the OL. Just like enzymes end in ASE, alcohols end in OL typically. And then once again, the organism would typically get rid of it in some way if it causes issues, because we know that alcohols actually will damage living tissues. Okay. So hopefully that kind of gives you a general idea. Tomorrow we will carry on from glycolysis with that pyruvate if oxygen is present. So fermentation is when oxygen's not available. And you notice that we really didn't get a lot of energy. So we love this new process when we took in those mitochondria because it helps us get more energy out. So we'll talk about that next. Bye.